So we're looking at a thermal decomposition over here. Very first thing, what should we do? Let's know their name. So we are looking at here lead, nitrate. Then we have, let me write over here. Lead oxide. Then we have nitrogen dioxide and we have oxygen. Agree? So all these are your IUPAC names. So next is balancing it out. So we have the reactant PbNO3 twice. Okay, and then the product PbO, NO2 and O2. Oh, this is supposed to be not there actually. Not supposed to give you guys this clue. Okay. Yeah. So this is a scenario. Now let's write all the atoms, nitrogen, oxygen. That's it. Now let's write the count. So here we have 1 nitrogen, it's 2, and oxygen is 6. 3 2s are 6, nitrogen it is 2. So let me write it for you guys over here. PbNO3 twice means there is 1 Pb and combined to this is 1 and the second pair of NO3. So if you count it, there are 2 nitrogen and 6 oxygen, right? Understand this is important. And then we have Pb, lead, and then we have no nitrogen, 1 oxygen. In NO2, we have no lead, 1 oxygen and 2 oxygen and 1 nitrogen. And in oxygen, there is 2 oxygen. Now the balancing part. So let's look at it. So 2, 2, 1 and 6. So this adds up to 5 and this is 6. So let's make it, no 6. Now it's 6. So since I want 2 oxygen over here, I need to have 2 over here. That's the only way we'll get 2. Next, since this entire thing is 2, PbO is 2, you have Pb to be 2. There are 2 lead atoms over here, right? So PbO, there are 2 lead atoms. So when you look at the lead on the LHS is 1, on the RHS is 2. So I have to multiply this with 2 as well. So this is a cascading effect. So we have to keep doing it. Pb to be 2, this entire thing has to be 2. So there has to be 2 of such pair, 2 of this. Since I'm doubling everything, so everything will get doubled by default. Now this is 2, that's okay. Nitrogen, here it's 4, here it's 1. So let's make it 4. Because I made this 4, that is I need to have 4 nitrogen, means what? This has to be 4. So 4 2s are 8, oxygen has to be 8. So I'll multiply this with 4. Now let's see if everything is balanced or not. 2 lead, 2 lead. 4 nitrogen, 4 nitrogen. 12 oxygen, 2 plus 2 is 4. 4 into 3 is 12. So this adds up to 12, this adds up to 12. So everything is balanced. Okay. So I'll do it once more. So very first step is what? Yes, write the reactant and the product on the top. Then write the atoms that are involved on the first very column. And then count. Just count. 1, 2 and 6. To understand this, just watch, not watch actually. Read this diagram. Look at this diagram. I'm just doing that with all the atoms. Then we have none, 1 and 2, none, and 2. So I can start with anything. Let me start with nitrogen. I'll show it to you guys. Actually, it will get complicated. Okay, let me show it. So I'll start with nitrogen. Since LHS is 2, RHS has to be 2, so I'll multiply this with 2. Because this is 2, right? For nitrogen to be 2 over here, NO2 has to be 2. Only then nitrogen becomes 2 over here. Is it not? We know the answer that this is not 2, this has to be 4. So I just undone that circle thingy. Okay, anyways. So here the oxygen count is supposed to be 4. I'll multiply with 2. So this is 4. This is 6 and 7. 6 and 7, this is not going to work out. It's not a good start. So I will go back to the start. So we have nitrogen not to be a good start. Let's start with oxygen. 2, 2 and 1, 5. It's easy to make 6 by multiplying with this with 2. Since I multiplied, or since I want 2 of oxygen, I have to make PbO, the compound, to be 2. Since PbO is 2, lead is 2. Since on the RHS, lead is 2, the LHS also, the lead has to be 2. For the lead to be 2, this entire thing has to be 2. Since the entire thing is 2, everything gets multiplied 2 times. So we have lead to be 2 and lead on the RHS to be 2. Nitrogen is 4 and this is also 4. It has to be so. Since this is 4, for this to be 4, the nitrogen dioxide has to be 4. Since nitrogen dioxide is 4, the oxygen atom over here, there has to be 8 of them. And so let's see now, this is 2, the lead on the LHS is 2, on the RHS is 2. Nitrogen, it's 4, and on the right hand side, the nitrogen is 4. Oxygen, it's 12 on the LHS, and here it is 2 plus 8 plus 2, that is again 12. As simple as that. Again, pause and try to do it. It's a very simple process. It's like Sudoku, playing with the boxes. Okay, so basically 2 times of Pb and O3 twice. We're supplying this with heat, and we have PO, which is solid, plus NO2, which is, yes, gas. Oh, sorry, this is 2, this is 4. And we have oxygen, which is again gas. And this is a solid. Agree? So that's basically your balanced equation. Now, how do you figure out that the reaction has happened? Quite simple. Gas formation over here. So nitrogen dioxide, it is going to be, let me write it over here, reddish brown. So this is a reddish brown with a bit of pungent smell, odor. Then we have oxygen, right? So that is also, this is colorless and odorless basically. So actually let me write it off. Oxygen, which is colorless and no smell, odorless. So the reddish brown fume of NO2 are particularly noticeable indicators. Then I think sound, this is endothermic, that is one thing. This is endothermic. So the surrounding, it gets a bit cooler. So this is the most fundamental thing that we need to know. And this is an extra bit of information. Why does it happen? So first thing is first, similar to all your decomposing reaction, we start off with this being a ionic bond, which is stable. When we provide with heat, what happens? It breaks. Okay, so PbO is also ionic, while your NO2 and CO2 is NO2 and not CO2, sorry, O2 is covalent. So basically, what do you think is happening? We are moving from PbNO3, which is stable and at a lower potential, lower energy state, to your product PbO, NO2 and O2, which is higher energy. What is happening is an upward movement. So energy is needed. Again, just get a feeling of it. Don't memorize anything over here. Just get a feeling. So all of this is there, So get a feeling of all the factors, then it will make sense in time.